How's it going, peoples? This video is to hopefully help you with horizontal projectile problems, also while calculating the final velocity and angle at the end of the story. And I just wrote down a simple sentence where something's thrown horizontally at 20 meters per second from a height of 4 meters, which leads to a variety of questions like how far does it travel horizontally? How high or how long is it in the air? Was this thrown by like a really tall person, like 11 feet tall, who can reach 13 feet above the ground? What is this object? Is it a book? Is it a ball? I don't know. Does its mass matter? I have so many questions, but I should probably stop wasting your time and get after this. As you know, X and Y are independent from each other when it comes to projectiles. So we suggest by making a chart. Then we also know that the horizontal velocity is constant. The acceleration is 0. So if this is physics 1, we are simply listing Vx, delta dx, delta t. If this is AP, you can do this as well. Some of you may prefer to list A and VI, VF, A, where A is 0. That's up to you. I'm going to list my variables vertically. Vertically, the object is in free fall, and it is accelerating. So I'm listing my 5 variables there. I mean, that's your opening, like right away. For every projectile problem, you shouldn't be like, okay, 20 meters per second, I got to write that down. No, you don't. It's a projectile. Set the table, and now let's fill in what we know. We do know that it's initially thrown at 20 meters per second. That's all we know. We also know that it's thrown from a height of 4 meters. Now, that means it's going to go down 4 meters. Therefore, the displacement in the y-axis is negative 4 meters. A very common mistake in the beginning is to forget this negative 4 because it's going down. Also, the initial vertical velocity is 0 meters per second. You know how I know that? Because it's thrown horizontally. So initially, at the moment of release, it's not going anywhere vertically because it's thrown horizontally. We also know it's a given on the surface of our planet that the vertical acceleration will be negative 9.8 meters per second squared. All right, now we're ready to go. I mean, I'm going to go through everything. I mean, I wonder how long it's in the air, how far does it go, what its final vertical velocity will be, and what angle does it make when it hits the ground. So let's get to it. Clearly, in the x-axis, right now, we can't do anything because we only have one variable. In the y, however, as hopefully you're getting more familiar with, we basically only have one choice. Math rep 3. VIY delta t plus 1/2 AY delta t squared. And you know what's nice? The initial vertical velocity is 0. That whole term goes away. So we have negative 4 meters equals 1/2 negative 9.8 meters per second squared times time squared. Now, if you were to divide positive 4 by negative 4.9, you'd realize you'd be getting the square root of a negative number. So that's a good hint that you probably forgot a negative somewhere. And it's not that you did anything wrong. It's usually that you made a sign error. I mean, really, how much can you do wrong? You have a couple expressions that you can choose from here. So anyway, we get a time of 1.28 seconds. Terrific. I will also figure out how far it travels horizontally. And if you're physics 1, that's math rep number 1, where delta dx equals Vx delta t. If this is AP physics, you'll be using the 1/2 AT squared equation where A is going to be 0. And in the end, you get back to this anyway. If you're more comfortable in AP using this equation, you are more than welcome to do so. Just do this. I believe they allow that on the AP exam as I ramble here. And we get a distance of 25.6 meters. All right. Those are the basics. If I want to know the speed at the end of the story, I know that it's traveling to the right and it's traveling down, and I need a way to combine those two things. But before I can do that, I have to figure out how fast it's traveling down. So I need the final vertical velocity. I am going to choose math rep number 2. Some of you may be looking at number 4 with the VF squared equation. Just remember, when you get your answer, the square root of a number is positive or negative, and you must make it negative. That's why I'm choosing this one, because I get an answer that's very direct. It says the final vertical velocity is this. and the initial y velocity is 0. So we get the final y velocity will be the acceleration times the time, which is 1.28 seconds. And we get a final vertical velocity of negative 12.5 meters per second. Okay. Now we know that the object is traveling to the right at 20 meters per second at the end of the story, right before reaching the ground, and it's traveling down at 12.5 meters per second. So we need to combine these two things. The first thing I would suggest is to redraw the x and y velocity vectors. That's a suggestion. I would draw Vx first, then attach Vy, so you get a good visual. What I mean by that is Vx is 20 meters per second to the right. So this is our Vx. But Vy attached to the Vx is 12.5 meters per second down. Negative 12.5 meters per second. If I were to draw an axis, an xy axis from where we started, it's very clear that we are down and to the right in the fourth quadrant. So this is the final overall velocity. That's to give yourself a visual. It's a suggestion. Some people do skip this step, but it helps me to visualize, okay, to the right and down, that's fourth quadrant, and I'm looking final velocity and the angle that it makes with the horizontal. Really, we have a right triangle, so the math should be pretty straightforward here. If I want to get the final velocity and I have the other two sides, I'm just going to use Pythag. I'm going to Pythag them. That is a verb, to Pythag. Vx and Vy. So the final velocity overall in this particular case is, again, just going with Pythag, a squared plus b squared equals c squared. I get Vf is the square root of 20 meters per second squared plus, I'm going to put the negative in here because I have to, but on my calculator I will not. Because what tends to happen is people don't use parentheses correctly, and what you end up with is 20 meters squared plus minus 12.5 meters per second squared, and it ends up just being minus. So it's going to be a positive number either way. I would not enter the negative in my calculator, or I would just make sure I use parentheses correctly. All right, so I got 23.6 meters per second. That is the speed at which it's hitting the ground. However, I don't know the direction. Luckily, I am a master when it comes to trigonomics. And in this class, we only use sine, cosine, and tangent. Right now, I know the opposite side from the angle and the adjacent side from the angle. Some people might be saying, yeah, but you know final velocity. That's true. I'm going to avoid that for a few reasons. But we already know the two sides of a triangle. All year, we're going to be doing Pythag, and then what you see here is inverse tangent to get the angle. It's all year. Instead of trying to figure out what to do, it's the same thing every time. So the final angle when it reaches the ground here is going to be the tangent inverse of the opposite over the adjacent. So technically this is the final angle, which is going to be equal, and you want to be in degrees. You know why? Because nobody likes radians. Nobody. Show the math teachers this, and I know they're going to be at my door. But I got an angle of negative 32 degrees. Okay, we need to talk about that negative 32 degrees. That negative 32 degrees is actually the angle measured this way below the x-axis. Now, I would accept 32 degrees below positive x-axis as an answer. That's fair. Another option is just to measure the angle counterclockwise from 0. So that would be 360 degrees, but we have to take out that 32 degrees, and we get 328 degrees. So either answer, 23.6 meters per second at 328 degrees, or 23.6 meters per second at an angle of 32 degrees below the positive x-axis. Both of those angles are fine. And that's about it. let's do a quick recap because maybe it'll help. Who knows? I feel like maybe just screenshot this stuff and put it in your notes. I don't know. That's kind of lazy. Don't do that. Sorry, I'm rambling as I'm trying to get this all lined up. All right. For projectile problems, X and Y are independent, so you definitely want to make an XY chart. The acceleration in the X is 0. The vertical acceleration is negative 9.8 meters per second squared at the surface of our planet. That's why for Physics 1, we only use MathRep 1 because it's constant velocity in the x-axis. But AP, if you want to list all 5 variables, that's fine. Just make sure you put AX is 0. You're still going to end up using the 1/2 AT squared equation. Delta T is the same for both. I didn't mention it earlier, but that's the key to these problems. In this particular problem, since it's thrown horizontally, we still don't know what the object is. You'll have to let me know what you think the object should be. The initial vertical is 0 meters per second because it's thrown horizontally. In the end, if you're trying to find the overall final velocity, my suggestion is to redraw Vx, then attach Vy. Theta will be the inverse tangent of always the y over the x, and the speed will be using Pythag. So you're going to hear me say all year, Pythag inverse tan. In fact, I don't know if we've done it yet. No, actually, I know we haven't. But we're going to be doing a lab where you have to find the initial velocity, which means speed and direction of a football when it leaves your foot after being kicked. So we're trying to find the initial speed and angle. And it's going to be the same technique. I suggest drawing Vx, then attach the initial vertical velocity, and then we're going to do Pythag inverse tan to get the angle. And that's about it. There might be a few things I'd change, but I'd still give this one, I give it 3 out of 5 stars. Hopefully it was helpful.